Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this is part 2 of solving trigonometric equations. In the previous video, I introduced trigonometric equations, and before we could start solving them, we had to review some topics that I've covered in previous videos. We talked about where the different trig functions were positive or negative. We talked about the unit circle. We talked about our trig identities. And we talked about working with our angles and our trig functions in radians. I want to continue with more examples so that you are familiar with the kinds of equations you might encounter. It's a good idea to have some reference sheets available when you're doing these equations. For example, have the unit circle available. It's going to make it easier for you to recognize the trig functions of the special angles. And I know that you might not be able to see this. Just look up the unit circle on the internet and there's going to be lots of examples of ones that you can print out for your use. And the other thing I recommend you have is the trig identities that I've discussed, which include the basic trig identities, the Pythagorean trig identities, and the double angle trig identities, because they're going to be very useful in solving these equations. So the first example I want to take a look at, I picked this example because I want to illustrate something that you may encounter. 2 cos squared x equals 1. First of all, we'll divide both sides by 2. Then we're going to take the square root. So it will be positive and negative square root of 1/2, which is the positive and negative 1 over square root of 2. That is the trig function of your special angles, but on your unit circle, it's not going to be expressed that way. It's going to be expressed with rationalized denominator. And the way that we do that is we multiply numerator and denominator by root 2. So this is also equivalent to positive negative square root of 2 over 2. And that's how the values on your unit circle are typically expressed. Just be aware of that when you get 1 over root 2. It's also equal to root 2 over 2. So I know that cos of x is equal to positive root 2 over 2 and negative root 2 over 2. This gives me 2 angles. Cos is positive in quadrant 1 and 4. This gives me 2 angles in quadrants 2 and 3. And my special angles, I go inverse cos. I can use my unit circle. So pi over 4 in quadrant 1, and then 7 pi over 4 in quadrant 4. Cos is negative in quadrant 2. So if I go inverse cos of that and look at my unit circle, I'm going to get 3 pi over 4 in quadrant 2, and then 5 pi over 4 in quadrant 3. So if I put all of this together, x will equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We can check that by putting each of these values into our equation and making sure it's true. So far, all of the questions I've done involve angles that are special angles. So we were able to find the values on the unit circle. We didn't need a calculator. But let's take a look at some other examples where they're just any angle. In this next example, let's isolate tan x by, first of all, isolating the term, adding 2 to both sides. Then dividing by 3. And then we can solve for x by going inverse tan of 4/3. 4/3 is not the tangent function of any of the special angles, so we are going to use our calculator. And we want our answer in radians. We want x to be between 0 and 2 pi, so that tells us that we want 2 answers and we want them in radians. So if you use your calculator, your first answer is 0.93 radians. That's the answer your calculator gives you, but you're going to be expected to find the other angle in your 4 quadrants that has a tan equal to 4/3. So that's where we need to know where tan and the other trig functions are positive and negative. We know that tangent is positive in quadrant 1 and quadrant 3. So if my amount of rotation is 0.93 radians, the angle in quadrant 3 will be defined as pi plus that amount of rotation. We always take the amount of rotation from the horizontal. So it's that amount past pi. So if I take 0.93 plus pi, we get 4.07. So the other solution is 4.07. So you could get questions that don't involve your special angles, and then you simply use your calculator. And remember that you need to find the second angle because your calculator is only going to give you the one angle. Let's take a look at some more. So far we've been working with equations that have just an x, the trig function with just an x. Sometimes you're going to encounter angles that are expressed as 2x or 3x or 1/2 x or whatever. So I wanted to show you how you would deal with these types of equations. So first of all, we're going to isolate cos of 2x. And when we're working with 2x, we know that x has to be between 0 and 2 pi. If we were to multiply by 2, if we were to take this expression and multiply everything by 2, so I get 2x, 0 times 2 is 0. 2 pi times 2 is 4 pi. So that means that this angle here has to be between 0 and 4 pi, which is actually 2 revolutions. That increases the number of solutions. If it's between 0 and 2 pi, that's only going to be 2 answers, typically. But when it's 2x, we're involving 2 rotations, so now we're talking about 4 possible answers. So let's find 2x. So we take the inverse cos of root 2 over 2. In our first rotation, it is a special angle, root 2 over 2. We know cos is positive in quadrant 1 and 4, so we just look at 1 and 4. And our angles are pi over 4 and 7 pi over 4. But those are the 2 angles just in one rotation. We go another rotation to get our next 2 angles, and the way that we find those is we just add a revolution to this and we add a revolution to this. So if we have pi over 4, we add a revolution which is 2 pi. Pi over 4 plus this will be like 8 pi over 4 gives me 9 pi over 4. It's the same angle as this, but it's in the next rotation. So 9 pi over 4 is my next answer. And then I do the same thing here. I take 7 pi over 4 and I add a revolution or 2 pi radians to that. So that's 8 pi over 4 plus 7 pi over 4, which is 15 pi over 4. So when there's a variable here, if the variable is 2, that actually doubles my number of solutions. I'm not done. I don't want to know what 2x is equal to. I want to solve for x. So I simply divide all of these by 2. So this will be pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. So those are my solutions, and when I'm just looking at x, all of these values are between 0 and 2 pi. Let's take a look at a couple more like this. Let's start this next example by isolating tan of 3x. So we're going to divide both sides by 0.5. Now, pay attention to the coefficient here. If we have 3x, that means we're going to have 3 times the number of solutions than if it was just an x. Because if I multiply everything here by 3, this angle is between 0 and 6 pi, which is 3 revolutions. 2 pi, 4 pi, 6 pi. So we're going to start off finding inverse tan of 1.5. That's not going to give it, that's not the tan of a special angle, so we have to use our calculator. So the inverse tan of 1.5 on your calculator will be 0.98. We want to find the other angle. We know it will be in quadrant 3. So to find that angle, our rotation is 0.98. We add 0.98 to pi, and we will get 4.12. If that was just an x, we'd be done. But we have to go through another rotation. So we add 2 pi to this and 2 pi to this to get my next two answers, which will be 7.27 when I add 2 pi to that. When I add 2 pi to that, I get 10.41. So now I've gone through 2 of the 3 revolutions. I have to go again, and then I add 2 pi to this angle. I get 13.55. And I add 2 pi to this angle, I get 16.69. So if that had just been an x, I would have had just those 2 answers. If that would have been a 2x, I would have had those 4 answers. I have 3x, so that the 3rd revolution gives me these last 2 answers. To get x, I divide all of these by 3. When I calculate these, I always work with the exact value on my calculator. So I didn't use the 0.98, I used the whole value that was there when I did all of these. So if you use these rounded off values that I showed, you might get slightly different answers. All right, let's try one more question. So I want to do a question where we have a fraction as a coefficient of x. Let's take a look. If we were to multiply everything by 1/2, that means that this angle has to be between 0 and pi. Now, not 0 and 2 pi. X has to be between 0 and 2 pi, but 1/2 x has to be then between 0 and pi. So I'm going to find 1/2 x by taking the inverse sine of 0.4. That's not a special angle, so I use my calculator, and I get 0.41 radians. So sine we know is positive in quadrant 1 and in quadrant 2. So my amount of rotation is 0.41 radians. To find this angle in quadrant 2, I take pi radians and subtract 0.41. Always the amount of rotation from the horizontal, and that's 2.73. Is that between 0 and pi? Yes, it is. Some of these questions, it won't be, because if the other angle is in quadrant 3 or 4, you're just going to have to exclude it. In this case, this is an angle in quadrant 2. It's less than pi, so I'm okay. But just be aware that sometimes you're going to have to discard one of your answers when you do find the 2 answers. To solve for x, I multiply by 2, and I get 0.82 and 5.46. Are these 2 between 0 and 2 pi? Yes, they are. So this can get crazy, especially when you get really large values as coefficients there. That tells you how many rotations, and that tells you how many times more answers you're going to have. So pay attention, be careful with these, know whether they're special angles and you use your unit circle and express them exactly, or if they're not and you just use the values on your calculators. You can check your answers by putting those values into the original equation, again making sure your calculator is in radian mode. I suggest that you practice these trig equations. They're not easy. It brings in so many different things that you need to understand and be competent in before you can even tackle this. So don't get frustrated with these if you're getting lost. Go back to those videos that I mentioned in part 1, and then this should become easier. Take care, and we'll see you on the next video.